So as I was saying, this is the last week of instruction. So a week from today, we have our third exam. And then within 2-3 days of that exam, I think I should be able to post your grades for the semester. So I think it is a good time for you to review your grades for the individual assignments, labs, and class exercises, etc. And let me know if I have misrecorded anything, because it is more of a mess to change your grade after they are posted. So it would be easier if you would kindly take a look at your individual grades. There is a document, exam3 information.pdf on the D12 site under the content folder exams. Take a look at it. So the third exam will be a few multiple choice questions like what we had in the second exam. 8 to 10 of them would be on the 6th and 7th readings, and the rest would be on stuff that we covered after the second exam. But that also means we have to use material from the previous weeks, because how can I ask a question on loops without asking you to write code using assignments and possibly input, output, etc. So it is those things you should know, but the focus will be on nested loops and functions and lists, which is the topic for tonight. You will see all these topics again in the next course, which is ICS 141, which uses Java, and the coverage will be at more depth. So you should be pretty fluent in everything that we covered here. Otherwise, ICS 141 could be quite challenging. So I would recommend that if you are taking ICS 141 in the coming semester, spend some time over the next month or so looking at all these topics, going over the assignments, trying to see where the gaps are and try to fill those, right? For example, you will see lists again in ICS 141, and they are called arrays over there. Of course, there are differences because it's a different language. That is one thing I wanted to say. Now, talking about readings, there was one reading where you read about the history of computing, and I wanted to say something about it. One of the big names in the field of computing is that of Alan Turing, who was a British mathematician, and he is considered the father of computer science. And the reason I am mentioning his name is the last weekend I saw a movie of his role in the Second World War. It's a gripping movie. You might want to watch that. It is called The Imitation Game. It was a really good movie, and you can learn a little more about the contributions of Alan Turing, who is perhaps the single greatest, contributor to this field, fundamental contributions. So I would highly recommend that you watch that movie so you get a sense of how things were at that time, what his contributions were, etc. I think it is important because you are in this field. I would highly recommend watching that movie after the exams, of course. Uh, that's all I have to say. Oh, yeah, right. About lab for tonight, I need to say something about that. But before I talk about the lab for tonight, do you have any questions for me?
About the grading criteria.
Sorry?
So
Yeah.
about the grading criteria that you had on that showed us the beginning of the semester.
Mm-hmm.
So the maximum points that you could get is 4 points, and you get an A. What about the minimum? If you score the minimum on all of them, what would your grade be?
It is given in the handout. So if you don't make the minimum, let me make sure that I am consistent with what I have written over there. I know what I have written, but I don't want to say something that is wrong. So maybe I can share the screen as well. Um, okay, here, let me share the screen. Okay, here is what I have. You need to obtain the minimum points here for
But
each.
these points don't add up to 700 points.
No, they don't. They don't. These are not supposed to be adding up to 700 points. These are the minimum that you need to get in each category. And this is the minimum that you need to get out of the total.
Okay.
Okay. So they don't add up to 700 points. But the category for the course grade is not only dependent on this. To get a C minus, you need to get 700 points, but also you need to get certain minimum points in different categories. Those are given here. Any other questions before we? Okay. Okay, and let me say a little bit about the lab. Okay. All right. Because it is slightly different this week from all the previous weeks. So please listen to this. So for the lab, you need to download a zip file from D2L, unzip the file, and one of the things you will see there is this document itself, and there is a Python file. What you need to do with that Python file, I will show you now. Let me share that. And, so hopefully this will, my explanation would clarify a few things. You may forget this, but still. That Python file is here. So this has a few functions. One is a function to implement sequential search, which you have read about in the uh, seventh reading. Then there is a function for binary search, which is implemented. You don't have to touch this at all, this function at all. Don't modify anything in this function. Then there is another function called experiment. Don't touch this either. Then there is a call to experiment, this function. Don't touch any of this. What you need to do, or one of the things you need to do, is modify this function declaration, because this doesn't have any code underneath the function header. So you need to translate the pseudocode, which is very close to Python code. So for example, the first line here says, store the length of my list in length. So my list is a list, and you need to store the length of it in a variable called length. You can see similar code here. So some of this code here would be very identical to the code in binary search. Actually, a good part of this code up to around here would be very similar to binary search. This code would essentially be, I'm not saying 100%, would be pretty much replace this part of the code. Then here is the actual sequential search. You have read about sequential search in reading 7. Sequential search is one way of looking for data in a collection, in a list. Binary search is a different technique. So let me briefly say what those things are, because they are things that you will see in the next class as well, but you need to be aware of these approaches this semester in this class that is expected. So let me briefly talk about sequential search and binary search. So searching is basically looking for things, right? So you have a list of contacts perhaps. So suppose you have a bunch of names, John, Mary, etc., Tom, Anne, and so on. And you want to see whether Mary is in this list. So you look for Mary here in this list, and she is there. You look for Dick, and Dick is not here. So that is searching. It is one of the most important problems in computer science, searching. Another important problem is sorting, which, and these were I think problems that have been known ever since we had this field. And they are highly researched areas. And tonight we will be looking at two search algorithms. One is sequential search, and the other one is binary search. What is the difference? I'm refreshing your memory here. In sequential search, we have the items stored in a list. So suppose that they are just numbers, 8, 10, 6, 2, 9, 4, 5. And you look for, say, 2. Is 2 in this list? What you do is you look at the first element. Is it equal to 2? No. Then you go to the next one. Is that equal to 2? No. Then you go to the third element. Is that equal to 2? No. Then you look at the next element. Is that equal to 2? The answer is yes. So you found 2. And then you say, maybe I found it as the fourth element, which is index 3. These are indices, right? 0, 1, 2, 3, 4, 5, and 6. So this is at index 3. That is sequential search. You start from the left end at index 0, and then you keep looking until you find a match, or until you say, I don't have anything more here. So for example, if you're looking for, say, 15, you will look at this, then this, then this, and this, and then you say 15 is not here. It's not here, right? That is sequential search. you're doing it in a sequence. You're doing this sequentially. So in the best case, you will just look at the first element and say, I found the element. In the worst case, you would have looked at all of these. So the average time for searching is n plus 1 divided by 2, where n is the number of elements. So the disadvantage is if you have a very large number of elements, this will take a little bit of time. So this is not a good idea for large lists. But if you have only a few elements, like 7 elements or 8 elements, whatever, then this is a simple algorithm to write, and it is going to end very quickly. So sequential search is good if you have a small number of elements, but it doesn't work well if the number of elements is huge. So we have other techniques, and one of those is binary search. In binary search, what you do is you put all the elements in a certain order. So if you have numbers, you could put them in increasing order or decreasing order. Let's put them in increasing order. So things are increasing. So 2, then 5, 7, 10, 15, 20, 22, 23, 30. So that is something you need to do before you do any searching. You have to put them in sorted order. So that is a little bit of work. So these are indices 0, 1, 2, 3, 4, 5, 6, 7, 8. Now suppose you are looking for 23. Is 23 in the list? What you do is you go to the middle element. What is the middle element here? 0 plus 8 divided by 2. So this is the middle element. So you ask, are you 23? The answer is no. So you can't make a decision yet. But if 23 is in this list, it has to be to the right of 15. So we look at a smaller list and ask that whether it has 23 in it. How do you do it? You go to the middle element of this, but there is no unique middle element because there are 4 cells here. The middle element could be thought of as this or this. Suppose you think of this as the middle element, you ask it, are you 23? The answer is no. But if 23 is there, it has to be to the right of this. So we again get a smaller list. There are only 2 elements now, and you pick the middle element here. There is no middle element. There are only 2 cells. So this we can think of as the middle element, and that is 23. And then you say, yeah, I found it. Right? Supposing you are looking for 1 in this list. You ask the middle element, are you 1? The answer is no. So we look at the first half of this list, the middle element of that. Maybe this is your middle element. You think of this as the middle element. This is not equal to 1. So you look at this list, which contains only 1 element, and this is not equal to 1. So you say, well, I couldn't find 1. So that is binary search. Binary search is very efficient. Suppose you had 1,000 elements to start with. After one comparison, you only have to look at 500 because you would either go to the first half or the second half. Then now, if you can't find the element you are looking for at the center of this, you go to one of the two halves. So that would contain only 250 elements, and it would keep on decreasing So the list size keeps decreasing by half every time you search. So if you have 1,000 elements, you would have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 comparisons at most. Roughly, it is logarithm of n comparison, roughly. That is an approximate number, but it is very close, maybe log n plus 1. Logarithm is going to grow very slowly with respect to n. So that is why it is a very efficient algorithm, but it is only good for a large lists because the algorithm is a little more complicated and there is a little more overhead. So if you have large lists, then you use binary search. So what you need to do is implement the code here. This should be fairly straightforward because many of the lines are going to be identical to binary search. And the rest of it is, the real difference is here. Now, just to give you a little bit of idea as to what is happening here, when you run this program, it will ask you for, let me show you the, I think it is easier to show using the lab handout. So here is the lab handout. When you run that program after implementing sequential search, it will let you see how well sequential search and binary search would execute. It asks for the size of a list. It will create a list of a certain size. So you have to say what that list size should be. So you are saying here, the minimum list size should be 10,000 and the maximum list size should be 20,000. And you need to create lists at increments of 1,000 each. So this starts with a list size of 10,000, computes the time for sequential search. That turns out to be these many seconds, a very small number. Binary search is actually a little less, you can see here. And for 11,000, you can see that the time is a little less than for 10,000. That is experimental error, okay? And it keeps, it should increase a little bit in general. So you can see that it is 160, 784, then 156, 329, experimental error, but then it increases to 178 something, 198, 200, 227, 236, 246, 309. And then there is a little bit of a problem here, I think, 265. So this is not quite right. There must have been other things that I was doing or something that might actually change the running time. Whereas for binary search, you can see it is 33,520, then 36,299, 32,131, 33,304, 36, 33, 34, 41, 36, 35, 35. So it doesn't really increase that much, not as much as sequential search. So you need to run this program for very small lists and very large lists. So you should start off with, after trying out the program for some numbers like this to see how to use it, you should run the program for very small lists, like from 5 to 10. Very, very small list, like, so you would say a 5, and then the ending list size would be 10, and then you can increase the list size by 1. For the other one, Then you try for very large lists. What do you mean by very large? Well, it depends on your machine to a great extent. You can try like 100,000 or even a million if you want it, and at 200,000, and in steps of maybe 10,000 or 100,000. If you try a million to 2 million, it may take a long time. But I want something that is large. Okay. Now, couple of more things here. You can see that there are two more things I need to enter. Generally speaking, sequential search is slower. So you run the sequential search fewer number of times. That is, for each list size, how many times do you want to run sequential search? Here I'm saying 100. For binary search, I'm saying 1000. The reason being binary search is usually quicker. So if I run it for a very small number of times, the experimental errors would be even more, because there is some inherent overhead for running these programs. They would dominate. So the actual cost of binary search wouldn't really be clear, or it would be less clear at least. Whereas for sequential search, the time is anyway relatively large for large lists. So you don't have to run that algorithm that many times. So you can run it for a fewer number of times. That is that. And after you complete this implementation of sequential search, and either as you are executing the programs or after completing the experiments, you need to answer a quiz. The quiz will have a few questions, multiple choice questions that you need to, like 6 of them, I think. You need to answer all of them. And then there are 3 other questions, one of which is to copy your code for sequential search that you implemented. You need to copy and paste it. You don't need to turn in a Python file. And for the very last 2 questions, you need to copy and paste the execution from the shell script, something like this, for the very small, for steps 9 and 10, right? So you will get the output. That output should be copied and pasted. That is the submission for the lab. You need to go to the quizzes section and open lab 12 as you are completing this lab. Okay. Any questions before we do the class exercise? There was a question, if the code runs and it doesn't output the same numbers as I get, does it mean something went wrong? No, the answer is no. You will get, even if I run the same program, I will probably get slightly different numbers, because it depends so much on the current programs running, how much memory there is, and so many factors. So you will not get the same numbers. So don't worry about that. But you should get the same kind of behavior. And you should also realize that machines vary in their processing power, the CPU speed, the operating system, the memory, everything. One thing I want you to do is, when you are running these programs, close as many things as you can and do not execute anything else. don't run your browser at that point, okay? Just run that Python program and it will finish in probably less than a minute or maybe a couple of minutes max. Just wait patiently. Do not run any other programs at that point. So close your browser. At least close things that might actually be downloading things. Close your Word, close all the unnecessary programs so that you are not interfering with your Python program. Maybe you can even close the Zoom video during that period so that it doesn't consume any bandwidth and it doesn't transmit video, etc. That will reduce the interference. You will get more reliable results. And what you need to submit would be the quiz on D2L, completely filled. There are 6 multiple choice questions, and there are 3 other questions. In the first of those 3 questions, you will copy the code, the Python program that you implement. Where is it? Let me see if I can find it here. I showed you before, right? That idle, yeah, this one. You need to copy and paste this function after you convert this to Python. That is one of the things you need to do. Then the other 2 questions, for the other 2 questions, you need to I'm trying to find the other, they keep going all over the place. So I have difficulty finding where they are. Yeah, here, okay. For the other ones, there are 2 questions. You need to copy the shell output showing your execution for very small lists and very large lists, whatever your program shows you, okay? You need to copy and paste these things. They are actually in steps 9 and 10. Any other questions before we close this? Okay, then I will go ahead and make the quiz available to you. I think the quiz is available for you to open, and let me create the breakout rooms. All right, the rooms are open. Please go to the room.